So welcome back friends, welcome back in another video tutorial from microbiology with Shagnik. So in this video tutorial we will going to discuss about confocal microscopy. Okay, so in previous video lecture we have discussed about fluorescence microscopy, right? So in that video lecture I have not mentioned about a problem associated with fluorescence microscopy, not only fluorescence microscopy but in case of each and every microscopic technique that we have discussed until now, that is those microscopic technique cannot produce any kind of 3D image. Okay, not only that, whenever we are using those kind of microscopy to visualize 3D image, it will create a fuzzy and murky image. Okay, but in easy words you can also say that those kind of microscopy will create a unclear, or since other words, blurred image. Okay, so now scientists develop another type of microscopic technique that is known as confocal microscopy, that will not only provide a bright and good image of the 3D specimen, not only that, it will also provide you the 3D image of the specimen also. Okay, so let's discuss about it. Okay, so this is the ray diagram of the confocal microscopy. So as you can see that you may find it similar to the efflorescence microscopy that we have discussed in our earlier videos. Okay, so but here the only difference from the normal efflorescence microscopy and confocal microscopy is we are using a pinhole structure extra. So what is the use of that pinhole structure we will going to discuss. So let's see this picture. So I have taken this picture from the Prescott microbiology book. So as you can see those beads, this is a large bead, this is a small bead. So whenever we are using any kind of normal traditional microscopic technique to visualize those kind of 3D images, the image will be blurred. Okay, so you can have the image something like this one. Okay, so can you understand each and every part, detailed part of the image? No, it is not possible. So now confocal microscopy will help you. Okay, so the actual problem is associated with light microscopy or any other kind of traditional microscopy that you are using when you are visualizing any kind of 3D specimen, that is the light will that are passing from or that are coming from each and every part of the object are entering to the microscope. Okay, and microscope uses each and every light to construct the image. Okay, and as a result the image of the 3D structure become blurred. Okay, so now our confocal microscopy will allow only one light from each of the plane. Okay, and this light, remember it very carefully, that this light is coming from the plane of the focus of the specimen. Okay, it is not coming from the parts of the specimen which lies above or below the plane of the focus. Okay, and that means there will be only one light for each and every plane. Okay, so each and every planes there are only one light which is allowed by the confocal scanning or laser microscopy, that is the full form of CSLM. Okay, that is confocal scanning laser microscopy. Now it should be obvious that there should be something present that are simply eliminating the other part of the light. Yes, obviously it is, there is a extra instrument that is known as our pinhole. Okay, so this is a aperture present above the objective. This aperture above the objective will eliminate each and every other lights and only allow the lights that is coming from the plane of the focus, okay, to construct the image. Okay, so now let's discuss about how it is constructed. So I hope you have understand very clearly that what is the problem that confocal scanning laser microscopy will going to solve. Again I am repeating, the problem is we cannot get 3D image, and the other traditional microscopy creates a blurred image of the 3D specimen, right? So both the problem will be solved by confocal scanning laser microscopy. Okay, so coming back to the ray diagram, I think you can easily identify it that this ray diagram is quite similar to what we have learned in epifluorescence microscopy. And if you are thinking about this, yes, you are absolutely right. The only difference is there is a pinhole structure. Okay, so from the beam or from the laser beam, the light is passing. Okay, so there is already excitation filter. Okay, so here it is important to know that if we want to perform the confocal microscopy, it is again necessary to stain the sample. Okay, and here we will use the fluorescent stain. Okay, that means you can say that confocal microscopy is nothing but a upgradation of the fluorescence microscopy. Okay, so let's come back in other videos. So in bright field microscopy, we are using chemical stain, right? In dark field and phase contrast microscopy, we are not using any kind of stain, right? And in fluorescent and in confocal microscopy, we are using fluorescent stain. Okay, so now here is the laser beam, or in simple words, the light source. So this is the excitation filter. So this excitation filter will only allow the light of that wavelength that have the ability to excite the specimen. Okay, so this is the dichroic mirror. This dichroic mirror will allow the excitation light to move downwards towards the specimen. Okay, so now I have already discussed in our epifluorescence video that here, for in case of excitation light, the objective lens will act as a condenser, right? So it will condense the light towards the specimen, as you can see. Okay, so now the specimen will normally be illuminated. Okay, so now the illuminated light will go back to the objective lens. Now the objective lens will act as an objective lens, and now remember it, the illuminated or the light that is coming from the specimen is known as emission light. So this emission light are of higher wavelength. Okay, and dichroic mirror will allow the higher wavelength to pass through. Okay, so as a result it will face a tube lens, and after that tube lens it will face the pinhole aperture. Now it is important to understand. So as usual, because up to that part we have done what other traditional microscopy does, right? That means up to that part, let me write it. Okay, so up to that part, the light that are coming are from each and every part of the object, right? So now what pinhole do, let's discuss. Okay, so now pinhole will eliminate all the rays which are coming from the parts of the specimen that is above or below the plane of the focus. Okay, again, so here the pinhole will eliminate the rays which are coming from parts of the specimen, okay, that lies above or below the plane of the focus. Okay, or that is what this image also shows, that is the rays which is from above optical section. And so rays from above optical section and the rays which is coming from above the plane of the focus are similar words. Don't get bothered about this. And Also rays from below optical section are eliminated. Okay, so it only allows the light or rays which is from optical section in focus. Okay, that means light which is coming from the plane of the focus for each plane. Okay, so this plane of the focus will be catched by the detector. Okay, so another important difference between the epifluorescence microscopy and our confocal microscopy is, here we are not directly observing via our naked eyes. Okay, so here the detector will be attached with a computer program. Okay, this computer program will take each and every digitalized information of the plane of the focus. That is so let me explain it more clearly. So here the rays from optical section is focus is catched by the detector, right? Now from the detector the computer will take the digitalized information of each of the plane that our detector forms with the help of the lights that is coming from plane of the focus in case of each plane. Okay, that means there will be multiple lights coming from multiple plane of the focus, right? Or multiple lights coming from multiple planes, right? Now this light will together, the computer will form a composite image. Okay, and this composite image will be bright and more resolved one than what we get in normal epifluorescence microscopy or another kind of microscopy that we are using. Okay, so I think you have understand again that pinhole, the job of the pinhole is it inhibits the rays which are coming from above optical section and the ray which are coming from below optical section. It only allows the rays which are coming from optical section in the focus to go to the detector. Okay, now detector will give a digitalized information of each of the plane that it have constructed with the help of the rays from the plane of the focus in case of each plane. Okay, now the detector will composite each of the information, the computer will composite each of the information that it gets. Okay, and create a more brighter and resolved image for you. Okay, so that's what I have written here, that the computer interferes with confocal microscope, receives a digitalized information from each plane in the specimen, right? So this information the computer will create a composite image that is very clear and detailed. Okay, or it can, the computer will also use those informations to create a 3D reconstruction of the specimen. Okay, or you can also say that the 3D image. Okay, not only that, the computer will also allow to view the image from three different perspective. Okay, because it allow you to view the image from various cross section. Okay, from Z cross section, from this one. Okay, that means it allows you to view the image from various cross section, as the image is meant, as it is mentioned here, that the computer can also generate views of the specimen using different planes. The top left panel, the image of the single xy plane looking down from the top of the beads, and the two line represent the two xz planes image in the other two planes. Okay, so for remembering purpose I would like to recommend you to just remember about this, that the confocal microscopy allows the viewer to view the image from three different perspectives. Okay, so that is the idea of the confocal microscopy. Okay, so again it is exactly the same of the epifluorescence microscopy, but the difference is it have a pinhole extra. Okay, this pinhole will only allow those light to go to the detector which is coming from the plane of the focus. Okay, and detector will transfer those light to a computer, and the computer will use each and every digitalized information to form a composite image which will be more brighter and accurate. Okay, so that is the idea, and with the help of this image you can construct a 3D image or you get more brighter image. Okay, and it is also allowing you to view the image from various perspective. Okay, so now it is time to understand for what kind of specimen detection we are specifically using our confocal microscopy. So confocal microscopy is used to detect the biofilms, okay, which is nowadays a most important concern in medical field, because the biofilm can also grow on our medical instrument, which can cause various kind of infection. Okay, and let me told you that there are various biofilms present. So let me told you that there are various kind of biofilms present who are resistant to antibiotics. Okay, that is why the treatment of biofilm is also very difficult. That is the reason it is a very important concern in our medical field, and those biofilms can be detected with the help of this confocal microscopy. So this is how a biofilm look like. This is a biofilm or a 3D reconstruction of the Pseudomonas aeruginosa biofilm. Okay, so this is a type of the specimen how it looks like under confocal microscopy. Okay, so confocal microscopy, again let's revise, there is only one addition, that is the pinhole aperture, right? Pinhole aperture will allow only those rays who are coming from the plane of the focus. Okay, and that means remember it that from each of the plane there will be only one light. Okay, and the computer will use those digitalized information to construct a composite image. Okay, not only that, the computer will also create a 3D reconstruction of the specimen. Okay, that allow us to visualize the 3D image. Not also only that, it also allow us to view the image from each and every perspective. Okay, there are three different perspectives. And what is the application of the confocal microscopy? We are using confocal microscopy to visualizing biofilms. Okay, so that is the video for confocal microscopy. So I hope this video will be helpful to you. Thank you.